Hi, welcome back to our demo series, AI/ML on Kubernetes and end-to-end workflow, featuring a use case where an ML model predicts customer churn or the likelihood that a customer will leave us for one of our competitors. This is the second in this series. In the first video, we gave you an overview of the AI/ML flow as shown in this diagram, from data ingestion to model training to model movement to production in an MLOps workflow to model serving for inference by intelligent applications. So next, we're going to start to drill into parts of the flow. In today's demo, it's the work of the data engineer, as you can see here. We're going to demonstrate how with Kubernetes, it's possible to alleviate several challenges that often slow down AI/ML workflows at this critical data preparation stage. It's vital to provide data engineers with self-service tools to rapidly combine and prepare data from various sources in order to produce high quality data for data scientists to train their model, because high quality models need high quality data. In today's demo, we'll showcase first how a data engineer can provision their own tools, in this case, a Jupyter Notebook, a Spark cluster, and an S3 object store, all independent of IT, allowing them to rapidly do their work with no tickets, no extended wait times for IT to provision hardware or software. And second, we use object storage on the left, where the data engineer pulls their raw data, in this case, 2 CSV files, combines them into one, and then pushes them again to object storage, from where the data scientists will later pull them, addressing a common problem in AI/ML, that is effective collaboration and handoff of work between different parties. So now I'm going to hand you to Faisal, who will do the actual demo.
Thank you, Tom, and thank you for a quick introduction. As Tom has mentioned, in today's demo, we'll be focusing on data engineer, and we will read 2 different CSV files. Taking our example of customer churn, one file will showcase us the customer personal data, and the other file will showcase us what products the customer has bought. So think of it as these 2 files coming from 2 different sources. The first source of personal data can be from CRM, and the second source from the product data can be from some Salesforce or any other system that your organization is using. And data engineer will use Spark to join these 2 sets and write the final output on another S3 bucket. So let's start with our data engineer. As Tom has mentioned, it is all provisioned on Kubernetes for the data engineer. So when I log in as a data engineer, I'll be thrown this screen where I need to authenticate myself, and that can be integrated with the organization IAM. So I sign in with my credentials, and it will give me the Jupyter Notebook where I can start writing the Spark code that we just explained. This Jupyter Notebook is also running on the platform. All this data is available on the GitHub and the files, so you can see for yourself even after this video. We have a merge data notebook. First thing first, I always do, I run the watermark. Is a good plugin that I always use. It helps you find out what versions of different libraries you are using and help me bring on consistency to take that stack and promote it to different environments across my organization. So you can see here, now, when I say watermark, it will give me all the libraries that I'm using alongside with the versions. Then first thing first, we start the Spark session. We provide some environment variables, for example, connection to the S3 buckets, like this. So the Spark can fetch data from S3. Then we start the Spark session, or try to connect to that session. Now here the magics of Open Data Hub come into picture. When I request a Spark session, it will automatically provision a Spark cluster, and it will give me the session to that newly provisioned cluster to me. Then what I do, I read the CSV file. You can see I'm reading from the S3 bucket, and the file is customer churn P1. This is the file which is mimicking one data source. It can be CSV, it can be RDBMS, it can be streaming data, it can be any other data source. But it has these few fields, which is general information, personal information of the customer, like gender and senior citizen status. Then I'm going to read the second field again from the Spark. There's a second file. This file is mimicking another system, which actually holds what customer has bought what product for this organization. So this is a second file. Again, it's going to the S3 bucket to read that file. And this file has the same customer ID field on which we'll do the join. And it has different products that customer has bought, yes or no. For example, phone service, streaming TV, and so on and so forth. Then what we do is Spark, we'll ask Spark to join these two data sets based on the customer ID field. And when the Spark join all this, it will automatically be distributed along multiple worker components of the Spark cluster, which is automatically managed for you by the Open Data Hub platform. And then once we have joined this data from two data sources, we are writing to another bucket in S3, which is full data CSV, which has the complete all the fields from these two different files and combine them into one CSV file. Now here we are just showcasing you the joining bit, but in the more complicated scenario, you can do all kind of calculation, you can do data cleansing, and many other capabilities that Spark offer you to process data. After that, once it's done, it will stop the Spark cluster so that resources that has been managed by Open Data Hub and Kubernetes can be utilized elsewhere in your cluster. So that's it from the data engineer part, and I'll send back to Tom so he can continue.
Thanks, Faisal, for the awesome demo on the work of the data engineer. So in the next demo, we'll be showing the work of the data scientist, who's going to pull this data that we prepared in this demo and start to build and train their models. So that's it for today. Thanks for watching.
Thank you.